Welcome to second steel making course, lecture 17. Let me speak broadly about this formation of non-metallic inclusions. In a short way, we call it as NMIs. In the last topic, I was talking about non-metallic inclusions classifications. What are the non-metallic inclusions? How does it influence? How does these non-metallic inclusions are formed? All those things are emphasized briefly. Now let me talk about these particular non-metallic inclusion formation. Continue to the last topic. First thing is nucleation of these non-metallic inclusions mainly occurs during deoxidation, desulfuration. Primary deoxidation generally happens in the primary steel making. Secondary deoxidation steps are concerned to the secondary refining process. Desulfuration usually takes place in the secondary refining stages. During these particular stages, the sulfur, dissolved sulfur is more in the molten metal, means there is a chance of sulfides. Sulfides are remained, sulfide inclusions. If oxygen dissolved content in the molten metal is lower, that means oxides are formed in the oxide inclusions are formed, more oxide inclusions are formed and floating at the top. These particular things are nucleation sites. Solutes, atoms of this particular molten metal and other addition of such as aluminium, oxygen. Now coming to this particular case, mainly this particular new phase formation such as inclusions. How do you determine these things? By wetting angle between the nucleus of second phase and substrate or matrix of this particular molten metal. If that particular angle is lower, wetting angle between this particular matrix and second phase is lower, it is a favorable condition to form new phase, new phase or nucleation site. And this particular nuclei does not stay stable, it continues to grow until it reaches to the chemically equilibrium under the temperature and pressure condition or it reaching till lowest free energy. It continues to grow till it reaches to the grain boundary. If it is smaller one, slowly it grows. If smaller inclusion is residing, smaller means less than 10 micron, it may not show that much harmful effect. It will reside within the grain boundary, it blocks at the grain boundaries just like dislocations, it increases the strength. But if it is macro inclusions such as Al2O3, CaO and SiO or carbides and nitrates, hydrates, it grows further and further, it forms entirely other grain boundary. So that is need to be avoided and it need to be removed. These particular inclusions at latter stage as the time is proceeding, it is a time temperature transformation phenomena. Basically the phase transformation, phase diagram, all those things comes into the picture. There will be collisions, collectively group formation and agglomeration. Things will occur even during the stirring action, during the teaming and treating of the steel. So these things will occur. Those agglomerates further grow. So with the form of agglomerate, if you allow to do in the Tunde stage, float up or modify the irregular inclusions into the spherical shape, you can remove those particular inclusion to the larger extent. This particular avoiding, if the surface energy is higher, there is a high chance of these particular inclusions coming together. Remember this particular point. Now let me talk about the influence of inclusions on mechanical properties of steel. If inclusions present such as hydrogen, combination of hydrides, carbon, nitrogen, oxygen, phosphorus, sulfur or combination. If hydrogen present, the internal soundness, internal strength of the material during the solidification comes down. If hydrides present, if carbon present, electromagnetic properties, electromagnetic nature comes down. Deep drawing, formability, if carbides, if the carbon is higher, formability reduces, comes down. If nitrogen present, it decreases the toughness of the steel. If oxygen present, it also decreases the toughness. It increases the surface defects, such as those are the stress concentrations, oxides within the grain, stress concentrators slowly micro crack initiate to the macro crack. The surface defects and good surface finish and rough surface will be there, and you need to machine to the large. Machinability is loss. And if oxide type of inclusion present, fatigue strength comes down, and the properties such as anisotropy, the properties, anisotropic properties, if you observe in one direction the properties are different, in another direction the properties are different, maybe the strength, the size effect is completely different. It shows anisotropy. And weldability strength, welding strength decrease if inclusions present at the weld bead. If these inclusions are deposited, the welding strength comes down. Bending, it is difficult to bend the material and deform the material. As a concluding, if the non-metallic conclusions in the steel 0.01 to 0.02% is existing present, it decreases large number of these mechanical properties. Let me conclude with the list: tensile strength drop, deformability, ductility decreases, brittlity increases, fatigue strength comes down, corrosion resistance decreases, welding strength decreases, machinability, loss of the machinability. These things will occur. Now let me talk about few more properties such as thermal expansion. If these kind of sulfide inclusions, as this particular calcium forms calcium sulfide, which is solid form, manganese is ductile phase MnH, these things have higher thermal expansion when you compare with the steel matrix. Behind the heating, during the hot working process, these particular sulfides are the concentration sites for forming the voids. That is why you need to be very careful. You need to remove these particular, or you need to reduce the sulfur content in the steel and sulfide inclusions during the tundish steel making process. And this particular void acts as the source for crack initiation. And if the inclusions such as oxides Al2O3, SiO2, CaO present, these things have lower thermal expansion when you compare to the steel matrix. These things leads to the development of residual stresses or internal stresses in the matrix of the steel, so that those are the concentration sites to the crack initiations. That is why these things need to be avoided. Now let me talk about the plastic properties or plastic strength, deformability during the art working process. Art working means it could be the art rolling process, art forging, art extrusion, any of these particular process. If these inclusions present such as sulfide, oxide, SHLE, it would be the combination of the fluorides, nitrates, hydrides also affects, but it is negligible when you compare to the sulfide and oxides. That is why we focus more on this particular sulfide and oxides. These particular calcium aluminate such as CaO and Al2O3, this O is capital O, please correct it, and Al2O3 inclusions it is becomes very difficult to deform at a temperatures of 1000 degrees Celsius and greater than the 1200 degrees Celsius temperature if these inclusions are present. That is why this particular structure spinel type it combination the ternary phase it forms CaO, L2O3 and SiO2. This kind of spinel structure it becomes difficult to deform even at the 1200 degrees Celsius temperature. If it is greater moving, it is becomes greater. Less at the lesser temperature, it is really hard to deform. And this particular when you vary this particular AB of this particular spinel structure, if A is replaced by such as calcium and iron and magnesium, if B is replaced by chromium and zirconium, all those things, titanium, this spinel structure is identified as if it is at greater it is deformable, at lesser temperature it is not deformable. And silicates are deformable at higher temperature if silicates are present, but at lower temperature it is not. That means you need to remove this particular such as oxides FeO and MnO. It is you will lose the plastic property ductility even above 400 degrees Celsius temperature. If FeO and MnO present, if Mn is present, it is highly you cannot you need to apply the more and more force even above the 1000 degrees Celsius temperature. So if it is at lower temperature you can manage to do, and if pure silica you cannot deform behind the unless until you go 1300 degrees Celsius temperature. And those things you need to remember as a concluding remarks. How do you control these particular inclusions? To control these inclusions, what do you do? At what stages these particular inclusions are entering into this steel? At latter stage of slab kind of steel, billet and bloom kind of steel, how do you avoid? During the tapping of molten metal into the ladle after secondary refining stage and taking into the continuous casting, what happens? If this particular 1 kg of FeO slag is carried forward from the tapping of steel, it allows to aluminum in the molten metal around 0.28. It decreases this aluminum retainability in the molten metal around 0.28. In overall, this aluminum react with the oxygen of FeO forms inclusions, Al2O3 inclusions around 0.5 kg inclusions. So you need to avoid this particular FeO slag. It could be the tundish slag, it could be the ladle slag, it could be the mold slag during the casting. All those particular things need to be avoided. Avoided this particular stage. And number of inclusions, if you see these particular things, if you carry forward this particular FeO slag around 240, and overall in 1 ton of molten steel, the inclusions observed are around 10 to the power of 10 to 10 to the power of 15. Even you cannot control all the inclusions. If the inclusions are less than 10 microns, these things easily float. It is an advantage for improving the strength. But macro inclusions greater than 10 micrometer inclusions need to be removed during these particular stages. And controlling during the treatment, argon inert gas treatment, this also causes the inclusions to float up. This is one way, one measuring treatment to follow, or reduce the carryover slag. All these particular tapping of steel from the vessel, ladle and mold, and during the casting, avoid those particular carryover slag. And controlling those particular inclusions, teaming from the ladle to tundish. If you use SRUD, the reoxidation, renitrogenization, hydrogenization, these things can be avoided if you use shroud and if you use proper Tundi slag, you can avoid the fluoride slag. This is, I replace this U with I. Fluoride inclusions may form. So you use the proper oxide such as CaO flux. Segregation, if the segregation occurs in the casting steel also, it leads to the inclusion formation. It need to be avoided. And controlling of inclusions during the solidification process or artworking process. And how do you do? Choose this particular temperature, 800 to 1200 degrees Celsius temperature. You can avoid these particular inclusions are acting as a concentrators and leading to the crack. Use this particular temperature, higher temperature, and use inert atmosphere to avoid the reoxidation from the atmosphere. And how do you modify if the irregular size of inclusions present in the molten steel stage? How do you do? What is the requirement? The first requirement is that particular element should have high chemical affinity towards these inclusions. It could be the oxide inclusions or sulfide inclusions. If it is Al2O3 and if it is MnS, what is the high chemical affinity element? And it should have the ability to modify the composition, overall composition of the liquid steel, reducing the sulfur, reducing the oxygen within the steel. What is that particular element? And it should be modify the shape of the inclusions, remove the sharp edges and corners of these particular inclusions into the spherical shape. What is that particular thing? The best treatment available is the calcium is widely used element for modifying the inclusion shape and size. How do you carry it out? Some properties of the calcium melting point is, and the solubility of calcium in the steel is 320 ppm, density is 1.55 and melting point is 1439, and it forms vapor pressure. If the calcium is 100% of calcium is added in the form of powder and putting into the encapsulated steel tube, it gives 1.5 atmosphere vapor pressure at 1600 degrees temperature. It means the calcium is evaporized. So how do you avoid that particular thing? So you use the combination of calcium and silicon. It brings down the vapor pressure to 1 atmosphere pressure during the tapping of molten metal, which is around 1600 degrees Celsius temperature. It remains if it is combined with the aluminium, if it is combined with the MnS also, it forms liquid with respect to the aluminium, with respect to the manganese also. It maintains at this temperature, even though aluminium temperature, Al2O3 temperature is around 2000 and CaO temperature is around 2500. Because of this particular property, it makes it remain during the tapping liquid state, so that you can avoid the inclusion, you can convert the size of the inclusions, and such as this particular, mainly to avoid to modify Al2O3 and MnS inclusions. And these particular Al2O3 inclusions are solid during the casting temperature and becomes brittle, leads to the crack. And these particular alumina will act as a blockage to the nozzle from the tundish to the mold. And this particular things also very important. Now, how do you avoid this particular blockage of this Al2O3 solidified Al2O3 MnS ductile phase of MnS? By using calcium treatment, you can maintain the Al2O3 at 16 degrees Celsius temperature liquid, even MnS also, so that these things will be avoided. These particular MnS inclusions present during the deformation process of artworking, it acts as a brittle flake or stringer type MnS will be formed. Now let me summarize the inclusion engineering and clean steels technology it is very difficult to make the steel inclusion free, but you can retain to the allowable content of sulfur, phosphorus, sulfide and oxide, oxygen around 300 to 600 ppm, sulfur to around the 0.04 percentage of sulfur is allowed in the steel. You need to make sure those things, and it is always important. It may or may not important to remove the inclusions completely from the steel. However, the size of the inclusion is bigger, then it need to be removed. And if the size of the inclusion is smaller, it is not required all the time to be removed. The smallest size of less than 10 micron size of inclusions can retain, it may help, in another words, increasing the strength of the steel. However, if the inclusions are modified, those smaller inclusions modified into the spherical shape, cutting down these particular edges and corners and converting into the spherical or global type, you can retain the smaller inclusions. That is why free from inclusions we do not call. The clean steel technology itself decreasing the larger size of inclusions, and then it is good. Now let me conclude this particular today topic, that inclusion present in steel after secondary refining process such as MNS, it reduces the toughness. If Al2O3 is present, it decreases the fatigue strength from the mechanical properties effect on the inclusions presence in the steel. Please give your opinion on this particular statement.